with a mission to foster technological innovation for the benefit of humanity. Today, in 160 countries, there are more than 80,000 student members. A student branch gives students the opportunity to meet and learn from fellow students and professionals in the field. IEEE student branches are established at over 1,500 universities and colleges throughout the world. Student branch activities offers numerous educational, technical, and professional advantages to IEEE members through special projects, activities, meeting, tours, and field trips. IEEE MNIT is a vibrant student branch. Currently, we have 8 active societies and over 60 student members. Collaboration, inclusive excellence, and collective efforts made IEEE MNIT to reach new heights in terms of events and number of student members. Dear participants, before we start, there are few instructions which you all need to follow during this webinar. You are advised to mute your microphone and please turn off your video. If you have any query or question regarding the talk, you need to write it in the chat box of Webex. And after the completion of the talk, Professor Puri will address those questions in the time allotted for question answer session. Now, I would like to invite our IEEE volunteer, Mr. Kumar Mohit, to give a brief introduction of Professor Puri.
Vivek.
Mr. Mohit.
Vivek.
Yes.
Is not clear.
Okay, sir, I am going to continue from here.
Okay.
Thank you, Vivek, sir, for the opportunity. Sir, I will introduce Professor Vincenzo Puri. So, good evening, ladies and gentlemen. Warm welcome to all of you. Today, I feel highly honored and grateful to welcome our speaker, Professor Vincenzo Puri. Professor Puri is a Master of Electronics Engineering, a highly decorated name in the scientific community, an ACM Distinguished Scientist, and IEEE Fellow to begin with a few. It's our esteemed privilege to have sir with us today. Professor Puri is in his 36th year of continuous and active service in IEEE, first as a student member and volunteer, and more recently as member of IEEE Board of Directors for 4 years, and IEEE Vice President for Technical Activities. Sir vast experience of holding prime positions at IEEE as Board of Directors, with his stack of knowledge in technology, on-hand experience as a leader, makes him the perfect man for today's session. Professor Puri received his MS and PhD in computer engineering from Politecnico di Milano, Italy in 1989 and is now full-time professor at University of Milan, Italy since 2000, where he was also department chair 2007 to 12. He was associate professor at Politecnico di Milano, Italy from 1992 to 2000, visiting professor at University of Texas at Austin, USA, summers 96 to 99, and visiting researcher at George Mason University, USA, summers 2012 to 17. Sir has founded a startup company, Sensor SRL, in the area of intelligent system for industrial applications and was active in industrial research projects with several companies. Professor Puri is known for his work in the field of information processing, with specific focus on artificial intelligence, computational intelligence, signal image processing, biometrics, industrial applications, measurement systems, arithmetic units, and fault-tolerant architectures. Professor has published 395 scientific papers in international journals and conferences and is listed as one of the top Italian scientists in engineering. He is editor-in-chief of the IEEE Systems Journal 2013 to 19 and an associate editor of IEEE Transactions on Computers since 2014, the IEEE Transactions on Cloud Computing since 2016, and Soft Computing Springer since 2011. He served as associate editor for the IEEE Transactions on Neural Networks 2001 to 4, the Journal of Systems Architecture Elsevier 2001 to 4, to list a few. Professor Puri has been at all chairing positions in conferences held by IEEE and has also been serving in the governing bodies of societies and council and has led with strategic planning at various positions. Sir had been awarded as an ACM Distinguished Scientist, an International Neural Network Society Senior Member, an IEEE Eta Kappa Nu alumnus, Honorary Professor at Northeastern University, China 2018, Amity University, Noida, India 2017, Muroran Institute of Technology, Japan 2016, Obuda University, Budapest, Hungary, 2014, and Guangdong University of Petrochemical Technology, Maoming, China, 2014, to list a few. Sir's vision of holistic view for one IEEE backed for his strong technical background, managerial experience, international visibility, positive attitude, understanding of IEEE activities has grabbed Professor Puri candidature for 2021 to 22 IEEE Region 8 Director-elect for 2023-24 IEEE Region 8 Director. Sir, experience, knowledge, and achievements is a panoply worth inspiring, and we can literally go all night stating them all. So now I would like to welcome and request Professor Vincenzo Puri to take the mic and enlighten us. Sir, please. Thank you.
Ladies and gentlemen, namaste. Thank you for this kind introduction. Today, I would like to talk about some issues and problems related to the use of artificial intelligence in some of the most valuable architectures for implementing a broad variety of applications. In particular, I would like to talk about the use of artificial intelligence in cloud computing and the Internet of Things. In this type of architectures, we can really deploy many applications by collecting the data from the environment, processing this data, and delivering the required knowledge and the required control to have the environment behaving as we want. We are going to have a quick look to cloud computing, to Internet of Things, which are the structures, and then we will look in details how we can use artificial intelligence to implement advanced applications, as well as to manage in a flexible, adaptive way this type of infrastructures. As you know, the cloud computing is an environment, is a platform that allow us to pick the relevant resources to implement our applications in a flexible way. So we can use the cloud computing as a platform for the infrastructure to provide services, to provide applications, as well as storage for the application. The value of this type of architecture is due to the fact that it is very scalable, first of all, and second, that we use it on demand. We use exactly the amount of resources that we strictly need when we need them. And this will simplify the use of the architecture, of the computing and storage architecture. So we do not need really to keep in-house in the company, in the public agency, the infrastructure, the computing and storage infrastructure in a dedicated way. So we can use these services provided to us in an adaptive way. In addition, it is important to point out that centralizing the service for storage and computing in a cloud service means that we can create a more secure environment, we can create a sustainable environment so that we can have better services, we can have dedicated personnel to focus on the security, maintainability, scalability of the system, managing the energy consumption so that we can benefit as customers from the advantages offered by these services, and we can benefit also from the reduction of the cost due to the scale of the system. In addition, we have managers who can take care of technical issues 24 hours a day for the entire week, since we can actually hire them in a reasonable way without having an excessive cost in our own computing center, in the computing center of the company. And this is why the cloud computing is becoming more and more attractive, especially for the small and medium companies. The cloud infrastructure is composed by a set of sites where we have processors properly connected through a network with the appropriate management, routing, and security protection. We are allocating the virtual resources as we need to the specific application so that we tailor the amount of resources that are really used in the system, limiting the waste of possible resources, of possible energy, and ensuring that we can support as many applications as possible. We can provide the infrastructure offered by the cloud computing as a service, but we can also provide basic tools, basic platforms, as well as the applications to build our own services, and on top of which we can run our own applications. There are several providers, and what we can also do is to note that we may have different tools, different services in different clouds. The multi-cloud model is taking nowadays a lot of interest in the community, since with a central broker, we can distribute the various activities and benefit from the best resources available, from the best application, from the best services available in the various cloud providers. With the Cloud Federation, this idea, this model is taken by the companies offering the services, the resources, so that they, instead of offering a separate cloud environment and the customer need to pick what is best for him or her, actually we have a federation so that all these providers come together and share the resources, share the applications, share the services, and they automatically, in a completely seamless and transparent way, they allocate the various activities requested by the users in the federation, picking what is best for each individual request of the users. On the other side, the Internet of Things is a modern infrastructure which is becoming more and more popular, especially thanks to the high-speed networks, especially the wireless networks that are deployed nowadays in many areas of the world, including the 5G networks or other fiber optic networks. This type of infrastructure are able to connect sensors and actuators at the border of the infrastructure to some computing and storage capabilities which allow to process this information and control the operation of the environment. And this can be used in a really broad variety of applications. Environmental monitoring, health monitoring, the smart cities, smart homes, as well as the manufacturing for complex systems and for many companies. This allows to have in the higher level of the infrastructure the processing element, the applications, and the storage, and we can reach from this infrastructure down to the elements which are providing information directly from the environment, from the sensors. So basically, the Internet of Things is a distributed architecture which is able to collect and process the data in a flexible, dynamic way. Is a pervasive infrastructure that can reach the environment in which we like to operate, is modular, is adaptable, and can support a broad variety of smart applications. This distributed architecture allows to support also various services. At the lower level, we have the basic processing of the data coming from the sensor and the data that need to be delivered to the actuators. But we may have some limits in the bandwidth, so we may not be able to bring all data to the central processing entity in the cloud due to the limit pushed by the huge amount of data that from the sensor need to go to the algorithms analyzing them. So we can have an intermediate model in which we deploy in the fog computing model some activities, some processing, some preliminary processing, which is able to extract some information so that we limit the bandwidth required to go to the higher level knowledge analysis in the clouds and push most of the computation down nearer as much as possible to the sensors and actuators. This is the fog computing model in which we have in the cloud model, in the cloud architecture, only the really high level analysis of the data, the high level extraction of knowledge, which is used to choose which are the activities to be performed in the real environment through the actuators. In the case the bandwidth is really high, the use of the bandwidth is really high, we may consider to go in the direction of an edge computing model in which we deploy the analysis and the extraction of the features characterizing the data directly near the sensors and so that we deliver only some limited amount of information in the fog or in the cloud levels. But this kind of global connections still have some aspects which are really important that we need really to care in the design and management. We need to have dependability for resilience, since we need to have the continuity of the service, even if we have some fault in components of the system. This is very important since we do want to have the applications continuously running, even though we have issues due to faults, malfunctioning, any kind of issues related to the hardware parts. But we need also to take care of the security. So we need to be able to continue the service, to be dependable, even if we have some attacks which are creating issues in a part of the architecture. So we need to confine, to limit the possible threat, the possible attack in some parts of the architecture, so that the rest of the architecture will be able to continue to deliver the service to the customers. And the same, we need to take care for the privacy, for the control of the privacy in order to ensure a seamless use from the point of view of the user, but the full control of the disclosure of sensible information. How we can use artificial intelligence in the cloud and the Internet of Things? Well, there are many companies which are investing in this direction, since the use of artificial intelligence is really critical to build modern applications which are able to learn, which are able from the real world, which are able to adjust to the evolving needs of the users, which are able to operate in an environment that which is not completely known in advance and which becomes known during the operations. We can use artificial intelligence and deploy the artificial intelligence by offering tools which are modeling the various artificial intelligence techniques and which allow to build our own application in a much easier way, since we do not need actually to build the specific software for implementing the artificial intelligence functions, but we can just use what has been deployed in the environment. And this is why the use of cloud environment, of cloud computing, is very attractive, since this type of environment allows the providers to deploy the services supporting the users also in the perspective of artificial intelligence components embedded in the applications, and allow also third parties to build additional services, additional components that can be used, that can be embedded in our own applications, so that we can benefit from all of these opportunities. There are also many services which are provided at the different abstractions level from the point of view of the data collection, the local data analysis directly from the sensor, from the sources of the data, up to the use of some basic services which model the data and extract some essential knowledge. And then we may have higher level functions, higher level services, which are able to extract and the knowledge, model the knowledge, represent the knowledge, support the users to take informed decisions on the basis of this knowledge. For example, with tools for visualizations, for easier user interaction by vision and speech interaction, or offering a group of use cases with effective building blocks which have been already exploited in other applications and that we may be able to reuse in our own application. Data mining is also an integrated, comprehensive infrastructure that is offered by many providers, so that in the same environment, we can take the data we collected and analyze this data with the appropriate techniques to understand which are the relationships embedded in the data themselves and extract a higher level view for possible future activities, as well as for decision making. Knowledge extractions are a set of other tools which are typically made available, not only by using appropriate databases which are analyzing the information, the objects, but also by using a knowledge-based infrastructure that gives a higher level view of the basic data which are collected from the environment through the definition of appropriate ontologies and semantic rule analysis on the data that have been collected by the system. And this will simplify a lot the analysis of the data, the creation of the abstract view as a knowledge infrastructure to be able to understand the environment and properly manage the environment itself, to understand the application, what is happening in the application we are considering, and properly manage the infrastructure and the application itself. At a higher level, we may have an even more integrated set of tools which constitute the environment of data analytics offered by several providers. We have the data coming directly from the environment, and we have the ability of defining the collection of the data, how the data are represented, how we are picking, analyzing the data at a lower level, how we are cleaning the data from possible problems due to noise or other outlier information. And what we can do is to use the services offered by the data layer, which define how the data are captured, how they are structured in the system, how they are managed from many different type of sources, not only from the sensors, but also from the social media, from website, and from many other sources that we may be interested in, so that we can capture from all these sources the information and bring all of them in an homogeneous way into the system for higher analysis, higher level analysis. Then we have the ability of aggregating the various components to create information which gives a detailed view of the real world that we are observing. So we can define rules for aggregating the lower level information into the comprehensive view. And then finally, we have the data analytic layer, which is able to map the view of the data that is contained in the database of the system in order appropriate views for the analysis. And finally, we have the tools which allow the consumption of the knowledge which have been extracted by the analytic layer by providing visualization for the end user to understand the data, to see the relationship between the elements between the various data, and to have a continuous observation about how the data are evolving, about how the knowledge is evolving, so that we can really observe the status and the evolution of the environment that we are observing. Finally, we have also tools which are able to build the view for decision makers, picking the relevant information that are extracted by the analytic layer from the data, so that the decision makers may have appropriate indices, which gives a concise view of the status of the systems, of the trends, and as a consequence, they can take actions to choose how the system should behave for the specific application that has been considered. What is important to point out is that the cloud infrastructure has been a significant facilitator of the use of artificial intelligence, since the availability of computing and storage resources on demand of huge amount of them allowed actually to collect enough information on which the artificial intelligence models and techniques can be tailored and can be configured properly to solve real world applications. This type of resources may not have been available for many years in the real specific environments due to the cost of deployment, due to the cost of ownership, but in the cloud they became affordable, and the system and this allowed actually to experiment much more and create many more real world applications for the benefit of the industries, for the benefit of the citizens, to support the activities of the government. The Internet of Things is the infrastructure which is able actually to deploy the intelligent processing in a distributed way, so that we can have the appropriate components working on the data as soon as they are generated, avoiding to bring everything in the central processing entities where we can store them and extract the view, the knowledge, and perform the activities that allow us to implement our specific applications. This gives much more flexibility, allow us to build the infrastructure, the components for our application, hardware and software, in a much more flexible way. But let's see how we can use the artificial intelligence on the other side to manage this type of infrastructure. There are many, many opportunities, from the selection of the services to the implementation and execution of the activities. Fuzzy systems have been and machine learning have been shown very effective to be able to define the service level agreement, and on the basis of the needs and the preferences of the users, even if they are not expert of the field, and as a consequence use the natural language to define their own needs. On the other side, the machine learning has been able to provide opportunities for extracting knowledge and information from previous use of the system, and as a consequence help in defining the service level agreement for this type of infrastructure. The use of these techniques also helps in selecting the appropriate cloud provider based on the services that we have specified. The neural network has been shown effective for cloud selection, and fuzzy system for specifying the preferences for the various characteristics. Evolutionary computing for the multi-objective optimization, so that we can choose the best provider by taking into account the various services, the performance, the quality of the services, and the price that they offer, picking the best configuration for all of them according to our needs. And then, of course, we need to distribute the task that we want to execute in the cloud, distributing the various tasks in the multi-cloud environment or in the cloud federation. And for this, artificial intelligence has been shown effective in the literature and in the practice to perform this allocation. Then when we want to build an application, we can specify the services that we want. And when we go in the market, in the cloud, to pick the appropriate services and compose them, we can use the artificial intelligence to support our choices, so that we can use the neural networks to perform the matching between our needs and the services which are offered, as well as the fuzzy system for defining the characteristics in a natural language that we want from the services. And the evolutionary computing is able to perform the multi-objective optimization. When we have the tasks that in the system, we need to allocate the resources to the various tasks in order to perform the required computation, the required activities. For this reason, again, the artificial intelligence has been shown effective, both for the static initial allocation, as well as for a dynamic reallocation of the resources to the various tasks. And the evolutionary computing is a very effective tool to perform the multi-objective optimization for this purpose. Then we need to place the various virtual machines in the architecture. And also in this case, the artificial intelligence has been shown effective. When we have the various activities in the structure, these activities are evolving. They have a trend of using the resources of the various activities, and we are interested in understanding which are the performances, how the activities are evolving, to understand if we can satisfy the needs of the various tasks at the desired level of quality with the desired performances. As a consequence, we can introduce techniques based on neural and fuzzy systems to make prediction of the activities of the task based on the current activities based on the previous execution of these tasks, and as a consequence to be able to predict the global workload that we may have in the system. This allows to understand when we have some critical situations. For example, the neural networks allow to detect a possible overloading in the system, or which may degrade the performance of the system, and allow also to detect a possible unbalancing of the architecture of the workload, so that we can consider to redistributing the computation, the activities in the cloud environment, balancing better the workload, and as a consequence getting better overall performances for the various tasks. Fuzzy systems have been shown effective to specify the preferences and evolutionary computing for the multi-objective optimization. In the Internet of Things, we have very similar problems, but at the level of the connection of the activities of the resources that we need to pick from the level of the sensors to the various components of the Internet of Things architecture to build the environment for our own application. But basically, conceptually, the activities are the same. We need to perform allocation of the resources in the Internet of Things infrastructure and possible dynamic reallocation of these resources. And again, artificial intelligence has been shown effective also in this perspective, in this type of infrastructure. On the other side, we may need to predict the performances of the various tasks to see if we are able to reach the level which is desired by the customers. In particularly, in the Internet of Things infrastructure may become critical the real-time operation, especially if we have a real-time, hard real-time constraints on the time by which some activities need to be completed in order to ensure the correctness of the operation of the system. For example, think in some manufacturing applications or in some mission critical application where the time is really a significant constraint, in healthcare, for example, too. This means that we need to predict the performances of the various tasks and the behavior of the entire system. We need to predict the workload of the various components in the system so that we can detect possible critical situations. And artificial intelligence has been shown effective also to detect possible unbalancing in the situation, the need for rebalance the workload, the distribution of the tasks in the system, and the possible presence of faults in the system so that we can adjust the allocation to ensure the continuity of service. Another very critical aspect is the prediction of the energy that we are using in the cloud infrastructure or in the Internet of Things infrastructure. Energy is nowadays a very critical resource since using too much energy is not only expensive, but has also an impact on the natural environment itself, since we need to generate the energy in a way or another. And if we are using not the renewable sources due to possible constraints in the accessibility of these resources, in the usability of these resources, we may increase the pollution that we may have in the environment. So we need to be very, very careful with this aspect. For this reason, having an analysis of the energy consumption, a prediction of the energy consumption is very important. And in this perspective, neural and fuzzy systems have been shown effective to create the appropriate model for this prediction, for classifying the level of energy usage, and for extracting knowledge from the past behavior of the system in order to better understand which are the trends and predict the future trends. We can use the artificial intelligence also for optimizing the entire infrastructure to avoid the bottleneck due to connections or processing components, and as a consequence to be able to ensure that we are able to reach the desired performances for the entire system. The fault management and ensuring resilience is also very important, since we need to ensure the continuity of service. As a consequence, it is important when a fault occurs to be able to dynamically reallocate the resources in the system to the task, to reallocate the task from one processor to another to ensure the continuity of service. We may need to duplicate the activities for each task so that if a task fails, the other one is able to continue to work and continue to deliver the required services to the user. In order to work in advance on fault management, we may need to have fault prediction so that we can create appropriate models by using many statistical techniques which have been shown effective, and we can actually work on predicting the possible occurrence of faults in the near future. And in this case, what we can do is proactively take a decision on the allocation of the tasks, on the allocation of the resources to the tasks, so that we can prevent that a fault in a component actually results in an issue to the users, in a possible failure of the application of the users. Security, I mentioned at the beginning, is another important aspect, and also in this case, the artificial intelligence has been shown effective to analyze the behavior of the system and detect possible intrusion and possible malware. Analyzing the logs that we collect in our infrastructure, we can actually understand if we had any intrusion, any attack, or if there is any malware which have been deployed in the system, and as a consequence, give a suggestion where this is located in the system, and eventually insulate this part, ensuring the continuity of service of the rest. The analysis of the trust, how much each component, each service is trustable, may be important as well from the point of view of the choice of the various services. And as a consequence, artificial intelligence has been shown a tool, an additional tool, to analyze and manage the trust in the entire infrastructure. In both in Internet of Things and in cloud infrastructure, we may have threats that may be detected during operation, which may not yet be critical, but may lead in the future to very critical situations from the point of view of security. And having an analysis of the possible occurrence of this situation is very, very important in order to be able to act as earlier as possible. In addition, the analysis of the trend of what is happening in the infrastructure may allow to predict possible security issues, may allow to analyze the vulnerability of parts of the architecture, and as a consequence, to take appropriate actions, either to insulate or to redistribute the computation appropriately, minimizing the total risk. In general, we need also the functionalities to observe the entire behavior of the cloud or of the Internet of Things infrastructure. And we need to have a concise view of the status of the activities, of the possible critical problems. So artificial intelligence has been shown effective to extract the relevant knowledge concerning the status of the system, of the infrastructure, providing a higher level view which is able to support a quick view for a quick understanding for the decision maker, for the managers, which may take appropriate action in the architecture. Finally, the cloud service and the Internet of Things have a price, and the setting of the price by taking into account the market, the trend on the market, the trends on the needs of the customers is very, very important to maintain the competitiveness on the market of the cloud and Internet of Things provider, and on the other side, ensuring sufficient revenue for these providers. Neural and fuzzy and machine learning techniques have been shown effective to analyze the trend of the needs in the market and the price, and as a consequence, to be able to set the most appropriate price for serving the customers. In this talk, we basically had two main contributions. We have seen that we can use cloud computing and Internet of Things with more intelligence embedded in them to create advanced applications, flexible, intelligent applications. So the artificial intelligence really can help in building the new applications. And on the other side, in this infrastructure, we can benefit of the use of artificial intelligence in order to manage in a more effective way the infrastructure themselves. So artificial intelligence has two roles in this type of infrastructure. From the point of view as a tool for building application, and as a tool to manage the infrastructure as well. It has been a pleasure to share with you this essential contribution, and it has been a pleasure, at least virtually, to be with you. Thank you. Thank you for having invited me.
Thank you, sir.
Sir, there are few questions in chat box, so I'm asking those questions one by one. Can I?
Sure,
there are
please.
few questions. Yes. Okay, sir. It is security of data is one of the main concern with cloud computing. How IoT is going to handle this?
We need to distinguish cloud compute. Well, actually, the problem of security is independent from the fact that it is a cloud or Internet of Things. In both cases, we have a distributed infrastructure, we have data, we have information which are flowing in the architecture. And as a consequence, in both cases, we need really to take care of the security. We need to be sure that we are able to observe, monitor, and protect the infrastructure from possible attacks. So there is no difference, since basically we are in Internet and we have these components connected to Internet. And there are many techniques which have been shown effective to protect the cloud computing infrastructure, the distributed infrastructure, and as a consequence also the Internet of Things infrastructure for from the attacks to security.
Okay, sir. Thank you, sir. The next question is in automotive industrial domain, as most of the automobile firms, as most of the automobile firms were using ECU, in which lot of CAN communication protocols are playing a very crucial role in synchronized way. Could you please let us know the role of cloud computing in ECUs?
Well, when you have a cloud computing infrastructure, basically you have something which is not in the car, but is separate, is available on internet. So you need to provide data that you want to analyze in an application which is in the cloud from your car to the application in the cloud. The critical point from the point of view of performance, connection, and service is therefore the link that the connection, the communication link that you have from the car to the internet, where you can reach your application in the cloud. Of course, you cannot expect to have locally to collect locally data to manage the operation of the car, move them in the cloud, and get back the results, the decision for control, the various activities when time is very critical. If you need to manage the engine or the brakes or any other activity in the car which is hard real time, consider, for example, many automatic braking in order to stop the car in the case anything appears in front of the car itself. All these type of functionalities require to have an immediate attention and immediate processing. So in this case, you need to move a part of the computation, not leaving it in the cloud, but move it in the car itself, where you can have a much quicker and sure interaction and sure operation. If you rely on the link to go to the cloud, you may not be you may not be sure about the time to perform the communication, and as a consequence, you cannot guarantee the time, especially when you have other real-time applications. What you can move in the cloud is something that does not require to rely strictly on hard real-time operation, and as a consequence, you can wait a little bit longer to get the answer. You may need to move to the cloud activities which may need a big amount of data. For example, you need to analyze a long history, a long database set of examples in order to extract relevant knowledge from the previous history. You may need to analyze a big amount of data coming from example, from traffic information, from the traffic flow, so that you can make appropriate recommendation to the drivers to use one route or another to reduce the traffic or to reduce the pollution. In this case, obviously, you need to have a centralized repository for this kind of information and knowledge, that since you cannot do this in a pervasive way in every car. But otherwise, you need to understand which are the functions that really need to be local with the functions that can be moved to the cloud.
Thank you, sir. Next question is, what is use of parallel computing in database and data mining, and how to work parallel computing?
Well, if this is not something which is strictly related to artificial intelligence, obviously, but may occur also in the case of artificial intelligence techniques, which are working on data in a distributed database. Obviously, you can have multiple databases in the network, and you may need to deploy your computation in the multiple databases. It depends with how the data are distributed and which is the task that you need to carry out in your application. If you can analyze the data in the various databases separately and extract some partial knowledge, well, actually you can conceive your application, splitting the application in parts, deploying the analysis in the machines which contains the database, extract the partial view from the data contained in the database, but you are not done yet. If from a logical point of view the database is if it is physically split, then you need to bring together the partial results and create the comprehensive view. So you can have some parallel operation when you have the tasks running on the different machines, but then you need to create the comprehensive, concise view, which is needed by your application. The use of the distributed processing helps in this direction.
Thank you, sir.
Thank you, sir. There is one very
welcome.
interesting question.
Sorry,
Yes, sir.
I'm looking to the chat to see which are the other questions.
Yes,
Okay.
sir. There is one question by Mr. Aditya Rai. Can we merge cloud computing with blockchain for better security?
Well, blockchain is not providing security. Blockchain is providing trust in the operations that we are doing, since it is certifying the various operations. So for sure, blockchain, if we need to have a certified sequence of operations, blockchain can help in this direction. If we are executing blockchain in an encrypted domain, this will add security to the operations which are performed in the blockchain, so that we are sure that we do not have alteration in the information which is carried on in the blockchain operation. Any kind, if we are talking about managing a cloud of Internet of Things infrastructure, the use of the blockchain can help in ensuring the trustability of the information that we are analyzing by ensuring the sequence of steps that by certifying the sequence of steps that have been applied to the data from the sources to the final user, so that to the final task, so that the user can be sure that the data arrives, the knowledge arrives from trustable data.
Okay, sir. Thank you, sir. There is one more question. It is, are we going to see world in future with complete dependency on cloud computing?
Well, the use of cloud computing definitely is attractive for many customers. As I mentioned at the beginning, small and medium enterprises may really benefit from the use of cloud computing, since the cost is much lower, the ownership cost is much lower with respect to building a computing center in the company itself, or paying an external provider for building and maintaining the computing center, the information center. The cloud computing infrastructure is a flexible model in which is much easier to deploy applications, and as a consequence is much easier, is an environment in which is much easier to manage the applications for the various customers. And this means that the cost of management, the cost of use of the services is reduced. The use of cloud computing also brings some better use of the energy, and as a consequence is attractive to reduce the cost itself from this perspective. On the other side, the fact that that a cloud provider can use an infrastructure continuously and offer the infrastructure as much as possible to a huge amount of customers implies that it becomes cost effective to hire experts of security, experts of resource management, to have the best management, the best security for the infrastructure. And as a consequence, the end users benefit also from the availability of the high security and efficient management. This is an added benefit for this architecture. Obviously, there are some critical applications that we prefer to maintain in an infrastructure directly owned by the company or the government agency, since we may want to control where the data and the processing are in the system. And in some cloud infrastructure, we can specify if data and applications must be in specific servers, for example, in our own country, so that data and processing are subject to the legislation of that specific country. And as a consequence, the owner of the data has a complete control of the activities performed in the system from the point of view of the legal liability. If these data are moved in another country, if the processing is moved in another country where there is a completely different legislation concerning the privacy, for example, I may not impose on that provider the same rules, the same limits on disclosing information that I can impose in my own country. And as a consequence, I may not like that my data, my processing is going out of the specific country in which I can have control about what is happening. In some very critical applications, we may want, for example, for national security, we do not want that the data, the operation may be subject to possible very critical attacks. So we may want to have a much stricter control on this. But this does not mean that we need to go back to the old style computing architecture, infrastructures, since we can implement a cloud computing model, several companies did in-house. So they may have, instead of the classic server for each of the departments or groups of department of the company itself may have built inside the company a private cloud where where the application of the company may run in a very protected way. The model of the infrastructure is still a cloud computing, but is not a cloud computing publicly available on internet. Is a private cloud of that company. So there are many opportunities. What is important is to distinguish the use of the cloud computing services offered by providers around the world from the computing model, the model of the computing infrastructure that we are using.
Thank you, sir. Sir, there is one more question on cloud computing. It is market giants like Amazon, Alibaba are efficiently managing multiple clouds to store data. How the small companies will do that as the number of clouds are growing exponentially?
Sorry, I don't see this question. Do you mean how the small company can build cloud computing infrastructures?
Yes, sir.
Okay. Well, of course, is a matter of competitiveness in the market. If I have a small company and in the small company I build a cloud infrastructure, I can offer the service of this infrastructure to possible customers. The problem is which is the cost effectiveness I may have. It may require some investment to have a sufficiently big infrastructure, hardware infrastructure, and it will require to have sufficient availability of experts in security, resource management, and so on, to properly manage the infrastructure in a secure way. Only if we are able to reach this kind of level, we can offer something which is trustable by customers, especially if the application is very, very critical. And on the other side, we need to have a sufficiently large infrastructure in order to distribute the cost of managing it on many more customers, and as a consequence have a lower cost per unit of resource that we are offering. So it will not be so easy to build a small cloud infrastructure. A small cloud infrastructure may be feasible in companies that needs to have in-house cloud infrastructure. In this case, small companies which are offering clouds services may consider to build this in-house infrastructure for this type of customers. But I feel that in many, many cases, it is appealing actually to work on the application, on tools for better managing the infrastructures, which may become much more rewarding from the point of view of revenues.
Thank you, sir. There is last question, and which is, as there are services present in Unified Diagnostic Services Protocol accumulated in ECU. So, according to the security provided by UDS protocol, is it better than security provided by cloud computing?
Well, it depends on the specific applications, on the specific techniques that we are using in communicating from the peripherals to the central cloud. If we do not use any type of protection during the communication, obviously we may have security issues. We may have intrusion, we may have damages to the data that we have. So it depends on which is the infrastructure. We cannot say that one solution is better than another. We need to take the appropriate actions to use the appropriate protocols in all infrastructure that we are considering, starting from the sensors, from the sensing level up to the global infrastructure that we are using. If we are considering an Internet of Things infrastructure and we do not protect the data which are coming from the processing entities, the processing units attached to the sensors, and we just protect the processing elements at the end of the chain, obviously we may have a lot of intrusion, a lot of problems along the entire chain. So we need to use, if we have a distributed infrastructure, whichever is the type of infrastructure, we need to look to the security techniques which protect the entire infrastructure. There is not one protocol which is better than another. Of course, if both of them are secure at the same level. If one has a very poor security and the other one has a very strong security, obviously there is a difference. But if the protection that they guarantee is the same, there is not an approach which is better than another.
Thank you, sir. Thank you very much, sir. So before concluding, I want everyone to please turn on your camera so that we can take one group photograph. So please turn on your camera. Turn on your camera. Please take some shots. Piyush.
Yes, sir. I have already taken screenshots.
Okay. Okay. Thank you, everyone. Now we are going to conclude this event. Piyush, please give vote thanks.
Okay, sir. Thank you very much for such an informative session. take privilege to extend a vote of thanks. On behalf of IEEE MNNIT student branch, I convey my extreme thankfulness to our Honorable Director, Professor Rajiv Tripathi, sir, who has given his consent and blessing to organize this webinar. Further, I convey my deep regards and hearty thanks to Professor Vincenzo, sir, who despite his very busy schedule, accepted our invitation as a speaker. We are highly motivated by his gracious presence and inspiring address. I now express my sincere thanks to Dr. Mayank Pandey, sir, the counselor of IEEE MNNIT student branch, for his constant support for the smooth conduct of the webinar. I further thank Professor V.S. Tripathi, sir, advisor of MTT and APS Society, and also convener of this event for his direction, guidance, and providing simulating environment for organizing the webinar. I now thank all the participants for their patience and cooperation with joining this webinar from different regions of country. IEEE is a professional society for you and by you. It is our support it is your support that keep us motivated and energized. Moreover, my sincere thanks to IEEE MNNIT student branch and Cisco WebEx Meet for providing their platform. A special thanks is due to volunteers Dr. Nankison sir, Saurabh Raj, Diksha, Aditya Pal, Kumar Mohit, and Vivek Rajput. These volunteers worked very hard to make this event a success. Last but not the least, we thank the Almighty God for enlightening the path of wisdom for us. Thank you, sir. Thank you very much.
Thank you. Namaste.
Thank you.
Namaste.
sir. Thank you.
Bye. Ciao.
Bye bye.
Sounds